So moving on after, or building upon the concept of fight or flight, we're going to talk about a couple things under the general adaptation syndromes known as homeostasis. And I had mentioned that earlier, where that's kind of where your body's going to try to form this balance of equilibrium between the positives and the negatives, and or overstimulation and understimulation. It wants to get to kind of a good equilibrium. So that's a balance and physical state in which all the systems are going to be functioning smoothly with one another, and they kind of counteract or balance each other out. So one thing on another definition on this topic here is adaptive response, and that's basically a form of adjustment where the body attempts to restore homeostasis. So body just basically likes to be at ease or a state of calm and equilibrium. So the general adaptation syndrome is basically a pattern followed in which the psychological responses to stress consisting of alarm, resistance, and exhaustion phases occur. So you've got three phases in this, that alarm, resistance, and exhaustion. So talking about the alarm phase, when the body is exposed to a stressor, the stress hormones kick in to do battle, which is going to be kind of that fight aspect of the fight or flight. And you have subconscious perceptions and appraisal of the stressor. So your body in a fraction of a second is going to perceive subconsciously what's going to be going on in that situation and tell your brain what to do for it to be responsible to specific emotions and reactions. The emotional stimulation then triggers a physical reaction that we associate with stress. So the entire process just takes within like a fraction of a second to a few seconds. So if you really think about this one, what really happens when you start to get exposed to stressors or major stress? More blood goes to the brain. Your hearing ability increases because all of a sudden you're more alert. Your pupils dilate to increase visual perception. The salivation can increase. Perspiration or sweating increases. The respiration rates increase. You start to breathe faster or harder. Your heart rate starts to increase. You generally can start to feel your heart rate. The digestive system slows as blood supply is diverted to other critical areas, which generally are the muscles or other types of area of the body where more blood use is going to be needed. Urine production generally decreases. Body cells release energy faster. So this is the component where after the stress is over with, you tend to feel a little bit more fatigued or tired or worn out. In longer periods of stress, you really feel exhausted mentally and physically. The ability for blood clotting increases. So if you think about strokes and heart attacks tied to stress, well, if your ability to blood clotting increases and your blood pressure increases through the arteries and through the heart, you have a lot bigger risk for certain side effects associated with cardiovascular diseases and stroke. And then tense muscles, of course, I'd already mentioned. So in the alarm phase, what happens is your mind perceives a real stressor, and what's known in your brain, a part of the brain known as the cerebral cortex, it's a region that interprets the nature of the event, is called upon. And if the cerebral cortex perceives a threat, it triggers the ANS. And the ANS is a portion of the central nervous system that basically regulates body functions that a person does not normally consciously control. So these are things that you're not actively always thinking of, but there's going on behind the scenes kind of in a silent and quiet way. And basically, in the long term, you start to see a lot of signs and symptoms as a result of the way your body and the brain is processing these and releasing the appropriate signals or chemicals. So if you think about a stressed out brain from a perspective of a wedding, what's really causing the stress? It's like budgets, snacks, foods, bridesmaids, picking dresses, the shoes, the weight of a woman or a man, flowers, boutiques, there's also like the rings that you have to buy. There's a videographer, a photographer, somebody who's going to facilitate the wedding, a guest list, a DJ, a honeymoon. All these things are causing stress. So you always hear about women during times of wedding planning, how stressed out they are. So I just like to throw this in there because it's kind of like the wedding brain stress. But if you think about it from the perspective of Homer Simpson, your brain has to interpret the nature of the event. So if you watch this show of The Simpsons anytime, there's only a couple things that comprise of him interpreting an event. That's sleep, donuts, do or don't, because you either get yourself in trouble or you don't get yourself in trouble, sweets, and beer, sex, TV time. So basically, your brain has to process and balance a lot of things, the do's and don'ts, how much sleep you're going to get, what you're going to do, are you going to risk in the behavior, and then ultimately stress can take its toll on a lot of things like sleep, It can suppress your appetite so that you're not going to eat, or it can increase your appetite in a lot of ways that you will eat. It can decrease your sex drive. So there's a lot of things that go on, and I just like to throw this in there because it was just a little funny slide if you actually have grown up watching The Simpsons. But essentially what I was showing you before in terms of the cerebral cortex is the part of the brain that perceives the threat. If you look at it on a CT scan image of a cross-section of the brain, the cerebral cortexes are right here where the red arrows are pointing. And if you look at a cartoon vision or a diagram of it, it's like right here on the smaller part of the brain, or the upper right part of the brain in this picture. So I just wanted to show you where it is visually, just so anatomically you're aware of what the cerebral cortex is or where it's located. So in the alarm phase, what happens is the ANS has two phases, and that's the parasympathetic phase and the sympathetic phase. The sympathetic nervous system is the branch of the ANS that's responsible for stress arousal. So it signals the body with hormones to determine whether it's going to take a fight or flight response, and the flight being give up on a situation. But then the parasympathetic nervous system is a part of the ANS that's responsible for slowing systems down that have been stimulated by stress response. So it basically counteracts the sympathetic effects. So if you've got one that's kind of over alerting your body and overstimulating, you got the other that's balancing and trying to get it back. Well, ultimately what you want is a good yin and yang, or you want a good balance. And so what you want to do is get the body towards what I had mentioned earlier of a good equilibrium for it to function, which is known as homeostasis. So these two systems, these two branches of the ANS together working are getting your body into a good equilibrium. Now, if you think about the parasympathetic division and the sympathetic division, think about what happens when you experience stress. Again, dilated pupils, inhibiting saliva production, dilates the bronchi, accelerates heart rate, stimulates epinephrine and non-epinephrine release, stimulates glucose, inhibits the stomach, pancreas, and intestines, inhibits urine production. Inhibiting meaning like slowing it down or not allowing it to happen as much, promotes ejaculation and vaginal contractions. And then on the side of the parasympathetic division, you have if you're dilating on one side, you're constricting on the other. If you're inhibiting one, you're stimulating on the other. If you're dilating the bronchi on one, you're constricting on another. Accelerating the heart rate here, you're slowing it down, and so forth. So basically what you're trying to see is that your sympathetic system kicks in to deal with the stress, and then eventually the parasympathetic kicks back in once the stress has surpassed to get your body back to an equilibrium that's something positive and more healthy for your body. So take a look at this and study the different effects that each of these branches has on the body, and just be aware of those and know these. Now, in the alarm phase, there's also a part of the brain known as the hypothalamus, and that's the section of the brain that controls the sympathetic nervous system and directs the stress response. So this region of the brain can signal adrenal glands if the body needs extra energy to deal with stress. So epinephrine is a hormone, also known as adrenaline. It stimulates the body system's response to stress. So I've given you that roller coaster example. Think about a scary high roller coaster again, and what happens before you even start to get on the ride. Your heart can start beating fast, muscles, or when you're on that top peak and you see that drop, what really happens? Your heart starts to beat a lot faster. Your air sacs in your lungs are becoming more dilated, so the oxygen intake has increased. You're increasing breathing. The signals to the liver release more glucose is broken down for muscle and energy, and the body is to act immediately on that stressor. So anytime you experience something immediate, like if you almost get into a car accident, you slam on the brakes and you get scared and you basically avoided a car accident by a fraction of a second, think about what happens. Your entire system within a fraction of a second to a few seconds does all of these things, and your muscles tighten up or you feel really tense and your heart's beating really fast. Well, so that's because there's a hormone on the epinephrine or the adrenaline that was released that triggered your body's ability to have to fight something that was immediately exposed to. Now, the hypothalamus, like I mentioned, it controls the sympathetic nervous system and the signals of the adrenal gland. So this is kind of where it's located in the brain, and this is earlier I mentioned the cerebral cortex, and that's over here. So I just wanted to show you this, and if you really look at like this diagram, just take a look at it and go through it in terms of what happens when it's triggering the adrenal gland, and then the target tissues is it increases the release of glucose from the liver, increases release of fatty acids that it's stored, increases heart rate, decreases blood flow through the blood vessels of like a lot of internal organs and increases blood flow to certain muscles of the body. It decreases functions of like other parts of the body in terms of a lot of the metabolic responses that you may have. It actually increases a lot of the metabolic reactions that you're having and your blood pressure. So kind of think about this, because what happens is when this hormone is getting released, it's actually putting you in a major flight stage, and it's taking a lot of energy away from your body. That if this continues for over a longer period of time, what's going to end up happening is that your body's just going to start to feel broken down and tired, and when the stress actually passes, that's when you get kind of into the exhaustion phase, because your body is prepped for fighting. It's been fighting for so long that it never reached a good homeostasis, and that now all of a sudden your body's just exhausted and tired, and you become immunocompromised in certain ways too, that you're more susceptible for other illnesses and sickness. So now there's a resistance phase, and that's similar to the alarm phase, in that the same organs in the system are mobilized but less intense level. So the body continues to return to homeostasis, but some stressors can still exist. So it's never going to get to a complete rest stage that's achieved, but you want to ideally get as close as possible to rest as you can. And if rest is not really achieved, the body stays activated and has higher metabolic rates in the organ tissue, and then you're basically just working overtime. And so what ends up happening is that you get into this exhaustion phase where your physical and emotional energy is just used up. And this time it's everything in your body's just been depleted, and you're more susceptible to illness. This is what I was talking about in terms of becoming immunocompetent. And that is so your immunocompetence is reduced. That means that your ability of your immune system to respond to different things, outside stressors or outside illnesses such as common colds or viruses or bacteria, has decreased, and you're more likely or susceptible to catch a common cold or become ill or become sick. So if your body keeps fighting, it's just going to over time get exhausted. That's why it's important to understand what a coping mechanism is for that situation, and you be able to deal with it should a situation arise again. So stress in cardiovascular disease is huge, right? So many studies have documented that there's a strong association between stress and elevation in heart rates and blood pressure, which I'd already mentioned. Well, that's strongly correlated also to heart attacks, because when you increase pressure, it can cause turbulence in the blood flow and damage the inner lining of the blood vessels. And when you damage the inner lining of the blood vessels, you're actually more at risk to basically allow fat to stick to the damaged sides of the blood vessels and in the body, and as a result you have atherosclerosis, which is a form of plaque buildup. So if you're susceptible already to overweight or fatty diets or high cholesterol, and you're always stressed and there's damage and your blood vessels are compromised, you're more likely to put yourself at risk for strokes and heart attacks because of the ability for the blood to clot and not be able to flow properly through. Another thing that stress has in terms of CVD is that if you take a look at this normal artery and the blood flow, it should be very smooth. But this is what I'm talking about in terms of atherosclerosis or plaque buildup. And so what happens is the artery is narrowed. So as the artery is narrowed, the blood flow through the artery is compromised more. A normal flow should look like this, where all the blood is accurately going. But what happens is when there's constriction to the artery or closing of the artery walls slightly because of fat or plaque buildup, you have blood flow that's going through and some's passing, but then others is kind of not going through as easy, and the flow of your blood is not as smooth as it is in this picture here. And a lot of times with the plaque as forms on the side, it kind of starts to build and build and build and close the artery up more, and eventually you have a clogged artery, and as a result you're more susceptible to have a heart attack because not enough blood is going. Or if some fat dislodges and it goes to the brain, it's able to clog important aspects of the brain up, and as a result you can experience a stroke. So stress and diabetes is another one. So you remember I mentioned the effect of stress on the blood sugar levels is a major impact. So a lot of times when you're under stress, we tend to either eat a lot, or we drink more, or we try to take on negative healthy behaviors that can affect blood sugar. Releasing of certain hormones also alter the blood sugar levels. High sugar levels due to stress will damage the body's organs such as the kidneys and other blood vessels or extremities to even the eyes, and therefore it can result in other types of issues of people developing type 2 diabetes, then which can also be correlated very strongly to heart disease.